everyone. This video is in continuation with our previous video is matter around us pure separation of mixtures. If you haven't seen that video, do check that as well. And if you like our videos, then please give a thumbs up and subscribe to our channel. In our previous video, we discussed separation of immiscible liquids as the last topic. Let us now discuss applications of the separating funnel used in the experiment. Separating funnel is used to separate mixture of oil and water. It is also used in extraction of iron from its ore. The lighter slag is removed from the top by this method to leave the molten iron at the bottom in the furnace. Let us now discuss how can we separate a mixture of salt and camphor. Below is the apparatus of the activity to be performed. We have taken an inverted funnel on top of a dish containing mixture of camphor and salt, which is placed above a stand beneath which is a burner which is continuously providing heat to the dish containing the mixture. We have previously discussed how in the process of sublimation, camphor directly changes into vapor, forming vapors of camphor within the inverted funnel. Here in this activity, heat is continuously provided to the mixture of camphor and salt, as a result of which camphor changes its state from solid to the vapor state. Within the funnel, the vapors of camphor can be observed. To separate such mixtures that contain a sublimable volatile component from a non-sublimable impurity, the process of sublimation is used. Here in case the mixture containing salt and camphor happens to be a sublimable volatile component, as a result of which when the heat is constantly provided to the mixture containing salt and camphor changes into vapor state. Therefore, we are able to separate salt and camphor. Few more examples include ammonium chloride, naphthalene and anthracene. Let us move forward and discuss, is the dye in black ink a single color? We shall discuss this with the help of an activity. Take a thin strip of filter paper. Draw a line on it using a pencil approximately 3 cm above the lower edge. Here we have the figure depicting a thin strip of filter paper taken and a line is drawn 3 cm above the lower edge of the filter paper. Put a small drop of ink, which is water soluble, that is from a sketch pen or fountain pen, at the center of the line and let it dry. Here in this figure, we can see the cross which shows the drop of ink on the filter paper. Now further, lower the filter paper into a jar, glass or a beaker or a test tube containing water so that the drop of ink on the paper is just above the water level as shown in figure B, and leave it undisturbed. Here in this figure, we can see that the filter paper is dipped into a beaker containing water. The strip of filter paper is dipped in such a way that the drop of ink is exactly above the level of the water in the beaker. Watch carefully as the water rises up on the filter paper. Further, record your observations. What do we observe on the filter paper as the water rises? Do we obtain different colors on filter paper strip? And what, according to you, can be the reason for rise of the colored spot on the paper strip? Let us now discuss all these questions in detail. The ink that we use has water as the solvent and the dye is soluble in it. As the water rises on the filter paper, it takes along with it the dye particles. Usually, a dye is a mixture of 2 or more colors. The colored component that is more soluble in water rises faster and in this way colors get separated. Let us now discuss this in detail. The ink which is dropped on the filter paper is soluble in water. Now, as the filter paper is dipped in the water particles take along with it the dye particles. Usually, a dye is a mixture of two or more colors. Well, now the component of the dye which is more soluble in water rises faster, as a result of which the color gets separated. Well, this process can be understood in 3 steps. The ink that we use has soluble components in it. As soon as the filter paper is dipped in water, the water takes along with it the dye particles. And component of the dye which is more soluble in water rises faster and gets separated. This process of separation of components of a mixture is known as chromatography, wherein chromato in chromatography stands for color. Chromatography is the technique used for separation of those solutes that dissolve in the same solvent. Here, in case of our activity, the ink that we use has water as the solvent and dye is soluble in it. Let us now further discuss various applications. To separate colors in a dye, like we discussed, pigments from natural colors, and drugs from blood. After discussing chromatography, let us now move on to discuss how to separate a mixture of two miscible liquids. Earlier we discussed that while separating two immiscible liquids, we took help of a separating funnel. Let us discuss this with the help of an activity. Let us try to separate acetone and water from their mixture. Take the mixture in a distillation flask, fit it with a thermometer, and arrange the apparatus in the following fashion. Let us now discuss the apparatus associated with the ongoing activity. We have a round bottom flask kept on top of a stand beneath which there is a burner. The round bottom flask consists of a mixture of acetone and water. We also have a condenser connected to the round bottom flask and a beaker at the end of the water condenser in which we will separate the acetone. Also, there is a thermometer attached on top of the round bottom flask. Let us now discuss the process of distillation. The mixture of water and acetone is slowly heated, keeping a close watch on the thermometer. The acetone vaporizes, condenses in the condenser and can be collected from condenser outlet. Water is left in distillation flask. This method is called distillation. Distillation is the separation of mixture of miscible liquids that boil without decomposition and have sufficient difference in their boiling points. Here in case we used a mixture of water and acetone which have sufficient differences in their boiling points and they do not decompose. To separate a mixture of two or more miscible liquids for which difference in boiling point is less than 25 Kelvin, fractional distillation is used. For example, for separation of different gases from air and different fractions from petroleum products. In our next video, we shall be discussing the arrangement of fractional distillation. In our today's lecture, we discussed how can we separate a mixture of salt and camphor. We discussed the process of chromatography and distillation. That is it for our today's video. If you like our videos, then please give a thumbs up and subscribe to our channel. Thank you.